In this video, we will discuss a new optimization algorithm, that is Chameleon swarm algorithm. This algorithm is basically inspired by the chameleon behavior, their hunting strategies in real life, that is simulated in this algorithm to find out optimal solution to different optimization problems. So this algorithm performance is tested using 67 different benchmark test functions that include unimodal, multimodal, hybrid function, and this algorithm is also applied to solve 5 different constrained real-life engineering design problems. And when the results are further compared with different meta-heuristics like PSO, evolutionary algorithm, Gray-Wolf optimizer, and other, this algorithm provides better results, better performance as comparison with other meta-heuristic algorithms. So we can use this algorithm to solve different optimization problems because this algorithm provides better results. Now here you can see this algorithm is introduced in year 2021, and the main inspiration behind this algorithm is the chameleon behavior in real life during hunting, different strategies they use for food search and other. So we have the virtual environment, virtual chameleons. So we will use different mathematical models to simulate all the real life behavior, their hunting strategies, how they search for the prey, how they track, pursue, capture, and in the end, hunt. So as the algorithm is inspired by the chameleon behavior in real life, so first we will discuss few facts about chameleon so that we can easily understand this algorithm. So as we know, chameleons are the attractive reptiles recognized by their unique features and capabilities. Like here you can see color change, eyes, tongue. So first we have color change. So they are famous for their ability to change color. This is used not only for hiding but also for controlling body temperature, communicating, showing emotions. Next we have the eyes. The eyes are highly mobile that can move independently of each other. This gives them a wide field of vision, the ability to look in two different directions simultaneously. So they use this capability also during hunting to capture prey and to observe their surrounding. And the third one, we have their tongue. So they have long sticky tongue that can shoot out quickly to catch prey. Their tongue can be up to twice the length of their body. And about their diet, you can see they feed on insects like flies, grasshopper, and chameleon large species may also eat small birds and other lizards. So they have excellent eyesight. They can see a wide range of colors, include UV lights, and how they defend against predator. They often move slowly and carefully to avoid action by their predators. And they can color change according to their surrounding that help them to hide, and also they use this to capture prey. So in Metaheuristic algorithm, we have exploration and the exploitation phases. In the exploration phase, the search agents will explore the search space and then here they are finding for the optimal solution. And in the exploitation phase, when any optimal solution is found, they converge at a point. So in this algorithm, in the exploration phase, they are searching for the prey. So they will search for the possible solution in the search space, and in exploitation means the prey is now detected, now they will hunt. So in this algorithm, this is simulated as refining the solution, that is the optimal solution. Here we have different steps they are simulated in this algorithm. First, it will initialize all the important parameters, like here you can see the PP, that is the probability value, random numbers R1, R2, R3, upper bound, lower bound, that is the search space boundary, dimension, population size, small t, that is the current iteration, max t, that is the maximum number of iteration. After that, we will initialize the position and the velocity for each search agents, and then we will calculate the fitness value using objective function. After that, in step 4, we will start the main loop here, define the parameters, then calculate the rotating center coordinates. After that, we will calculate the new position, fitness values as we updated their position in the search space. Now we will calculate the new position's fitness value. After that, we'll check the boundaries for the new solutions, whether the new solutions are within the search space boundary or not, and accordingly update position, increment the counter until the stopping criteria is met. And once the stopping condition is met, we'll stop and display the best solution. So now step by step we will try to understand how this algorithm is working. The first parameter we have here, pp, the value for this is used here 0.1. that is the probability of the chameleon perceiving prey. The fixed value we are using here 0.1. After that, we have 3 random numbers. They are used in this algorithm, and the range for the number we have between 0 and 1. They are normally distributed, lower bound, upper bound, and the dimension that we can define according to your objective function. Dimension, or you can say here we have the total number of design variables. Accordingly, we can update these parameters. After that, now step 1, we initialized all the parameter. Now step 2, we will initialize the position and the velocity. So first we have the center of the current position of the chameleon, that is denoted using this. T denotes the current iteration and I is the position. That is the current position of the ith chameleon. Suppose if we have maximum iteration 100, number of search agents, suppose we have 10, then for the first search agent it would be 1, and here iteration is 1, then 1. For the second search agents y, here would be 2, 3 up to 10, and accordingly in iteration wise we will update the current iteration. After that, we will rotate the centered coordinates of the chameleon, the small m, that is the rotation matrix that is used to represent the chameleon rotation, that is the centering coordinate at any iteration t, and the value for the center coordinate is calculated by using this, that is the current position of the chameleon minus its previous position. After that, value for m, that is the value for rotating matrix, is calculated using this. With the value for theta, we have here this one, capital R, that reflect the rotation matrix in the respective axis. Like here you can see for x-axis we have rotation matrix, then here for the y-axis the value for theta we have this one. This is used to calculate the rotating centered coordinates for the chameleon. After that, we will initialize the population randomly for each search agent in the current population. Lower bound plus random number into upper bound minus lower bound. After that, we will initialize the velocity. So as we discussed, they have long sticky tongue that they can shoot out quickly to catch the prey. So here we will initialize the velocity, and then we will calculate the fitness value. So here we will apply the objective function to calculate the fitness value for each search agent in the current population. After that, we will start the main loop here, check whether the current iteration is less than or equal to maximum iteration. If the condition is true, then we will define the parameters. So here we have different parameters, like first we have mu, that is used to explore the random locations in the search space. The value for mu we can calculate using this. Next we will define the weight inertia, that we will calculate using this. Small t is the current iteration, capital T that is the maximum number of iteration. And after that we'll define the acceleration rate. So acceleration rate of the chameleon tongue projection, it increases gradually until it reaches its maximum of 2590 meter per second square. So we will calculate this using this equation. So we will define all the parameters. So we calculate the value for all the parameters. For more detail, you can check the main research paper where everything is discussed in more detail. We will discuss the different steps they are using, mathematical models, how they simulated the chameleon's strategies in this algorithm to find out the optimal solution. For more details like the value for gamma, value for beta and other, you can go through the research paper. After that, we will start the main loop here. The first mathematical model we are using here for prey search. Now we will search for the target. So here from 1 to n is the population size, I equal to j to d, that is the total number of dimension. We will start the loop here. For each search agent, we will update position. So here we will check if the random number that is normally distributed is greater than or equal to pp. That is the probability of the chameleon perceiving prey. The value for this is used 0.1. We'll check here so we'll compare the value with the random number. If this condition is true, then we will update the chameleon position for the next iteration using this equation. Here you can see t plus 1, current iteration plus 1. It means the value is used in the next iteration. Right now we have t value 1, it means in the first iteration. So 1 plus 1, here 2. It means the value for this in the second iteration. This is the current position of the ith chameleon in the ith dimension. T plus 1, here t plus 1, that is the new position of the chameleon for the next iteration. Pt, this is the best position. Gt, that is the global best position. R1 is any random number. And then global solution, global best solution minus the current position, R2, any random number. For second case, this is again the current position, value for mu, that is the parameter that we are using to explore the random location in the search space. Apply the value here, upper bound, lower bound, any random number, and accordingly. After that, for 1 to n, we will calculate the chameleon new position after the rotation. So that we can calculate using this equation. Rotating centering coordinate of the chameleon in the search space plus its current position. After that we have the hunting phase, and for this we will use this mathematical model. So for all the agents in the current population, now we will perform hunting. So first we are searching for the prey using these mathematical equation. So when the prey is found, we rotate the center coordinates, and after that now we will perform the final hunt using these mathematical model. So for this, first we will calculate the chameleon current velocity, and then we will update the position. So here using this equation, we calculate the velocity for the chameleon, that is calculated using this equation. So the velocity here, we are calculating the velocity of the chameleon tongue when it falls forward prey, that is simulated using this mathematical model. So this is the new velocity for the chameleon, that is calculated using this. C1, C2 the constant, R1, R2 the random number. This is the global best position, VIZT. This is the current velocity, global best position, current position, and the personal best, and then its current position. So when the velocity is calculated, we will add the velocity value in the current position. So this is the current position plus the velocity value that we calculated here minus the previous velocity of the chameleon divided by 2 into acceleration rate that we can calculate using this equation. After that, we will calculate the new position fitness value. So here we calculated the new position, here you can see. Finally, we will apply the objective function to calculate the new position fitness value. After that, we will check the boundaries. After that, we will check the boundaries of the new solution, whether the new solution that we obtain, they are within the search space boundary or not. And if in case they are not within the search space boundary, then we will replace that solution with other, or we will reject these solutions. And then finally, we will update the position, increment the counter. In the current iteration, we will add 1, and we will repeat this loop until the stopping criteria is met. And once the stopping condition is met, we will stop and display the best solution that you found in the last iteration. So here we have this new optimization algorithm. First, we'll define all the parameters they are used in the algorithm and also in the mathematical model. Then initialize the position and the velocity for each individual. Then calculate the fitness using objective function. Define the parameters like where we have mu to explore the random location in the search space, to define the inertia weight, acceleration rate. Then perform the search for the prey using this mathematical model. We will search. update the position according to the search. We will update the position of the agents in the search space, and then we will start the hunt. For the hunt, calculate the velocity, then in the current position add the new calculated velocity and update the position. And here, when the position is updated, we will calculate the new position fitness value, and after that we will check whether the new solutions are within the bounds or not. And final update, increment the counter, repeat the loop, and display the best solution that you found in the last iteration. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.